Hi, friends. Welcome back. Miss Bertuman here. Today's lesson is all about determining if a whole number is a multiple of another number. Let's get started. For our first problem today, I'm going to need a friend to help me out. Meet my friend, Mr. H.
Hello, friends.
Mr. H is going to help us skip count. Mr. H, can you please skip count by fours for 30 seconds? And I'd like you to start at 0. And then, of course, only count as fast as I can write. Are you ready?
Sure am. Are you?
I sure am. Let's get started. In 3, 2, 1, go.
0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64.
Time's up.
Wow, that was fun. Students, pause the video here and take a look at the numbers that Miss Bertuman wrote down. What do you notice? Be ready to discuss when you get back. Miss Bertuman, what did you notice?
I noticed so many things. I wonder if you noticed the same thing too, students. I noticed that there was a pattern. All of the numbers here in this first column have a 0 in the ones place. In the next column, the second column, all of them have a 4 in the ones place. Here, all of the numbers have an 8 in the ones place. In the second to the last column, all of the numbers have a 2 in the ones place. And in the last column here, all of the numbers have a 6 in the ones place.
That is a great observation. Let's continue counting where I left off. This time, students, please count with us. And as you count, think about the patterns that you see. Are you ready?
I know I am. Let's count. Starting the clock in 3, 2, 1.
68, 72, 76, 80, 84, 88, 92, 96, 100, 104, 108, 112, 116, 120.
Let's quickly review. We're skip counting by the number 4. When we skip count by a whole number, the numbers that we say are called multiples. Please whisper that word with me now. Multiples. Go ahead and pause the video here and share aloud the patterns that you noticed when counting by multiples of 4. So what did you all notice? I noticed that all the multiples of 4 are even numbers. Did you notice that too? Also, the pattern that we mentioned earlier in the ones place has a consistent pattern of 0, 4, 8, 2, and 6. It just kept happening as we counted over and over again. This pattern in this ones place continues forever. Why is that? It continues on forever because it's always 4 more, and it just continues on with that cycle. How is a multiple different from a factor? Go ahead and share out your thoughts. When we found factors of a number, we listed them and then we were done. For example, the factors of 4 are 1, 2, and 4. With multiples, we could keep going on forever and ever, just like the multiples that we've written here. Is 24 a multiple of 4? Yes, it is. How do you know? Perhaps you counted by 4s and got to 24, like this. 4, 8, 12, 16, 20, 24. Maybe you already knew that 4 times 6 equals 24. Maybe even you divided. 24 divided by 4 is 6. So 24 is a multiple of 4. Is 24 a multiple of 5? No. How do you know? We know that 5 is not a factor of 24. When you divide 24 by 5, you end up with a remainder of 4. Is 96 a multiple of 3? What can we do if we're not sure? We can use long division to see if 96 is divisible by 3. Go ahead and pause the video here to use long division to determine if 96 is a multiple of 3. We'll compare afterwards. So is 96 a multiple of 3? Yes, it is. Here we can see that 96 divided by 3 equals 32 with no remainder. Another way that we can solve if 96 is a multiple of 3 is if we use associative property. 96 equals 12 times 8. Let's go ahead and factor 12 as 3 times 4. Since we're determining if 96 is a multiple of 3, we need to associate 4 with 8. What is 4 times 8? 32. We're now going to solve 32 times 3. 2 ones times 3 is 6 ones. 3 tens times 3 is 9 tens. So 32 times 3 equals 96. So yes, 96 is a multiple of 3. We just proved it again with associative property. Let's prove it again one more time using associative property. On your own, I'd like you to show how 96 is a multiple of 3 while using associative property. But this time, let's try it with the equation of 24 times 4. Think, how can we factor out 3? Pause here and we'll compare afterwards. Welcome back. Go ahead and take a moment to compare your work with mine. With this new equation, I have 96 equals 24 times 4. Since we're trying to factor out 3 to see if 96 is a multiple of 3, I factored out 24 as 3 times 8. I then associated 8 with 4, since we wanted to check for 3, and 3 times 32 equals 96. Let's take 5 seconds now to write down how many multiples of 6 that we can think of. Are you ready? Starting the clock in 3, 2, 1, right. Ooh, time. Here's my list. I'm wondering, is there any multiples of 6 that are also multiples of 2 and 3? Let's see if we can use associative property to figure this out. 60 equals 10 times 6. Remember, we want to determine if multiples of 6 are also multiples of 2 and 3. So, on your own, I want you to go ahead and pause the video here and use associative property to show that 60 is a multiple of 2 as well as 3. We can factor 6 and write it the following way. Let's now associate 2 with 10. Ten times 2 is 20. So our next equation is 20 times 3. 20 times 3 equals 60. 60 is a multiple of 3. Let's now associate 3 with 10. Ten times 3 is 30. So our equation is 30 times 2, and that equals 60. 60 is a multiple of 2 as well. We're now going to use a letter to represent the number of 6's to see if it's true for all 6's. N times 6 equals n times, open parentheses, 2 times 3, close parentheses. Let's now associate the n with the 2. N times 6 equals, open parentheses, n times 2, close parentheses, times 3. Let's now associate the n with the 3. N times 6 equals, open parentheses, n times 3 times 2. I'd like you to go ahead and pause the video here and explain why these equations are true. If it helps, go ahead and try plugging in 4 or 5 as the number of 6's, n, to help you understand. We'll discuss afterwards. Welcome back. How did you do? We can see that all of 3 of these equations are true. It's just that it takes twice as many 3's to get to multiples as 6's. So the multiples of a number are also multiples of its factors.
Students, your must-do problems are here on the screen. Go ahead and set a timer or watch the clock for 10 minutes to continue working on these problems. Of course, if you have additional time, feel free to work through any other problems on the pages.
Today's lesson was all about